Good evening, everyone. Like in the morning session, we are trying to discuss about the priority queue related information. So we identify the add all method as well as this particular retain all. So what we are trying to discuss here, we are trying to discuss about the differences between remove all as well as retain all. What exactly this particular remove all method is doing internally? Remove all basically whatever we are going to match it with this particular record. So this is basically TS like tree set records, and this is the another object I'm trying to create something like a priority queue. So these are all the some priority queue object we are having. It's going to store with 0 to 10 records. Getting the point? 0 to 9, it is trying to create a 10 records here. Now what we are doing here inside this particular tree set here, we are having 4 records here. Okay, these are all the 4 records we are having. Now what I'm doing here, i'm trying to I'm trying to remove with help of this particular remove all method. So what it will do, whatever the records are going to match it, this particular 4 records internally inside this particular priority queue. So those 4 records are going to remove here. Get in the pen. And remaining as it is, whatever the remaining object we are going to have inside this particular priority queue, all the records we are going to print as it is here. Only this particular 4 records we are going to remove from this particular priority queue. So this is the remove all method. Now, and another important method here we are going to discuss retain all. Okay, retain all method. So retain all basically again I am going to pass same the priority tree set here. The tree set will contain 4 objects, and the priority queue will contain the same 10 objects here. Get in the one. 10 objects. So this particular 10 object internally it is stored under this particular PQ. PQ is nothing but priority queue. This is we are going to call it as a tree set here. So using this particular retain all method, what we will do, it will look up the matched records here. So whenever this particular matched records are going to satisfied, the 4 records will keep as it is. The 4 records it's going to keep as it is, and remaining records are going to remove from this particular priority queue. Getting the point? Remaining whatever the records we are going to have, those records are going to remove from this particular priority queue. Now, and if we observe the comparison between these two, remove all method basically it will remove the only 4 records, whatever the records are going to match it. So here it is trying to match this particular 4 records. Whenever it is matched this particular 4 records, it will remove only 4 records it is going to remove. And whatever this particular retain all, only it will keep 4 records. And here only will remove, we are going to remove 4 the matched records here. Okay, so 4 records. And here we are trying to keep only, will keep only 4 records. Getting the point? We'll keep only 4 records here. So this is important, we need to understand, and the remaining unwanted records are going to remove, because so only the 4 records are going to match it. How many records we are going to match? So those records we are going to keep under this particular priority queue. Okay, and here only 4 records we are going to remove, and the remaining records we are going to keep as it is. Remaining records we are going to keep as it is here. So this is important information. We need to understand how this particular how this particular remove all as well as this particular retain all methods are going to match there. Here we are removing only, here we are trying to remove the matched records. So here based on our the tree set object here, only 4 matched records we are going to remove. And here based on this particular same tree set here, whenever we are calling this particular retain all, will keep 4 records. See carefully. Here we are trying to keep only 4 records, and the remaining records we are going to remove from this particular priority queue whenever we are calling this particular retain all. And the same thing from this particular priority queue, when we are trying to call this particular remove all method, only the 4 records are going to remove here. So this is the differences between remove all as well as retain all method. Now we'll see how this particular example it is going to work internally. Now here I'm trying to call this particular retain all. After calling this particular retain all, so how many records we are going to have? We are going to identify. So this is the records we are having so far. This is the records we are trying to have so far here. Now, if you see, if you match this particular record, first one is matching 65. Okay, inside this particular tree set, and 78 also it is matching as a second record, and the third record we are matching as a 85, and fourth record it is matching as a 148 here. Okay, this is important, we need to understand. But if you see carefully, we are calling the retain all. Now whenever I'm trying to call this particular remove all, so that we can easily understand how this particular the differences it's going to work internally. Remove and remove all, remove and remove all here. Okay, now I'm trying to run same example one more time. But if you see, if you compare this particular object here I'm trying to pass this particular object information. Now you can see the 65, 78, 85, 148, these objects are no longer available. When we are calling the, when we are trying to call the remove all, whatever the records are matching here, okay, whatever the records are matching with help of this particular tree set, only those records are going to remove from this particular priority queue. So after removing this, we are trying to return this particular object. And whenever I'm trying to call this particular retain all, only matched records we are keeping. Only matched records we are keeping. And whatever the unmatched records we are going to have, the unmatched records we are going to remove from the priority queue. Getting the point? So this is the differences we need to understand from this particular remove all method as well as retain all method. Okay, this is very important example we are discussing here. So any questions here? So anyone having any questions regarding this, the remove all as well as retain all method? Okay, if we don't have anything, now what I will do, so the remaining method, like here the clear and equals hash code, we no need to discuss this because we already familiar with from the previous example how it is going to work internally. Okay, now the final implementation class I'm trying to discuss here, but observe carefully what exactly the final class we are going to discuss here. So something like we identified the priority queue. The priority queue, it is extending from this particular abstract queue, and internally it is trying to implementing from the one of the interface call, one of the interface call queue interface here. And here I'm trying to write array dq. Getting the point? Array dq demo. So this is the demo I'm trying to write here. But now observe carefully how we can write here. So this is the class I'm trying to create, array dq. We'll see how this particular example will work here. Now again, I'm trying to work on this particular generic type. We can go for the character because this is the last implementation class we are going to discuss here. Because of this, I'm going to use character information. Okay, whenever I'm trying to use this particular character, we'll see how it is implemented internally. First, we need to understand this particular array dq internally implemented. So later I will discuss about the constructor. So first I'm trying to go to this particular class here. Getting the point? Array dq internally, it is extending abstract collection, not from the abstract queue. So observe carefully, this is important here. This particular class internally, it is extending from this particular, internally it is extending from this particular abstract collection. Okay, abstract collection, not from the abstract queue. Abstract queue is extended by this particular priority queue. But here, whatever this particular array dq we are trying to write here, this is internally, it is extending from the abstract collection, and it is implementing from the, this particular class is implementing from the queue interface. Okay, and sorry, not this. So this is implementing from the DQ. Okay, this priority queue internally is like implementing from the queue interface. So observe carefully, priority queue is a subclass and it is extending from this particular abstract queue, and abstract queue internally it is extending from this particular abstract collection, and so this is the queue interface we are having, and this particular queue internally is extending from the collection. Okay, collection interface here. Getting the point? And the same way, if you see, and another implementation class we are discussing, this is array DQ. Getting the point? Array DQ internally it is extending from this particular abstract collection, and it is implementing from this particular DQ, and DQ internally it is extending from this particular queue interface. So this queue interface internally it is extending from the collection. Okay, is internally extending from this particular collection. So this is the hierarchy we need to understand here. So observe carefully, collection is a super interface, and the super interface internally it is extending from this particular queue interface. Getting the point? And this particular queue interface internally is implementing on this particular DQ here. Okay, so DQ is also one of the interface we are having, and this particular DQ is implemented by array DQ, whatever the class we are having. Okay, if I will write the whole hierarchy, we'll understand very clearly what is the topmost class we are having. Sorry, what is the topmost interface first? Later we'll go for the class here. The topmost interface. Instead of writing this here, I will open the paint here. Where is the miss paint? Okay, so this is important. Okay, here what we can understand here. So collection. Okay, collection is interface here, and so collection interface internally it is extending multiple interfaces. Like first one is something like list interface, and second one is set interface, and here between we can keep this so we can easily. And these are all the interfaces we are going to write here. First one is a list, second one is a set, and the third one is queue. Okay, if I'm going to write here list interface here, and this is we can call it as a set interface, and this is we are going to call it as a queue interface. Okay, these are all the interfaces here. And internally what we need to understand here, this particular interface internally it is extending from this particular one interface we identified, and internally if you see, so one more interface we are having. Okay, these are all the important information. Sorted set, and here so navigable set. These are all the interfaces, and here this particular queue also internally it is extending from this particular interface called DQ. Okay, these are all the interfaces. Getting the point? These are all the interfaces we created. Now we'll discuss about the classes section. First I will discuss about the topmost class. Here only I'm trying to write here the topmost class here, something like abstract collection. Okay, abstract collection is the one abstract class we created for this particular classes. Now internally, what it will do? It will try to implement from this particular collection interface. Okay, and instead of writing this, so here I will write here. This is important here. Here only I'm trying to write this particular abstract collection. Okay, now observe carefully. This is important. We need to understand here. Abstract collection, and this particular abstract collection internally, it is extended from multiple classes. The first class, it will try to extend one class. Here I'm trying to write here. Instead of writing from middle, we can take abstract list and abstract set here and abstract queue here. These are all the three classes. Getting the point? Here only I can write small words here. So shortcuts I'm trying to write here for this particular abstract classes. Okay, now observe carefully. First one is AL. Okay, abstract list, and here abstract set, and here abstract queue. Okay, this is the abstract classes we are having. Getting the point? Abstract classes. And what is the relationship we are having here? The relationship we are having here, implements here. Getting the point? Here we are having implements here. Okay, and these are all the extents here. And here also we are going to write all the extents here. So this is also same. And what about this particular classes? Here we are going to use the keyword called extents, and here also we are going to use extents, and here also, and where we are using the implements, here collection is an interface. Getting the point? This particular collection is an interface. We are trying to work on this particular abstract class. Whenever I'm trying to work on this particular abstract collection, we need to use the implements keyword. But in all the cases, we are using the extents. So here also we are going to use the same extents. Here also we are going to use the same extents here, because type is same, interface to interface. Getting the point? Interface to interface. Now we are trying to discuss about the implementation classes. What are all the implementation classes we are having? So this is important. We need to understand the first implementation class I'm trying to write here. One by one here only we can write here. So first one is array list. Okay, and so later we are trying to discuss about the linked list. Okay, and so the another abstract related section we are going to write here something like hash set, and another one linked hash set, and we have one more class here, so that is something like tree set. Okay, tree set. Now if you see, this is the hierarchy we are going to have. Abstract list, internally it is extending from this particular array list. Getting the point? Internally it is extending from this particular array list here, and the same way the same abstract list, it is internally extending to this particular class also, something like linked list. Now observe carefully how we are having the relation. So collection, internally it is implementing this abstract collection, and abstract collection internally it is extend to this particular abstract list, and abstract list internally it is extending array list and linked list. So these are all the subclasses. Array list and linked list are the subclasses, and we can call it as a these are all the concrete classes. Concrete class basically it will fully implemented classes. Getting the point? So this particular class also not implemented fully, the AL, and this particular abstract class also it is not implemented fully. Okay. Same way this particular array list is also not implemented fully. So which classes are implemented fully? These two classes. Okay. Array list and linked list classes are implemented fully. Same way, and if I'm going to discuss about this particular one more class here, abstract set here. Abstract set internally is extending from this particular hash set, and the same way it is extended to this particular linked hash set, and the same way it is trying to extending this particular tree set. Getting the point? And these are all the concrete classes. These three are the concrete classes. Now what you are understanding is these three classes fully implemented here, like fully whatever the methods we are having, this all the methods are implemented inside this particular these three classes here. Getting the point? For this particular abstract set, what are the implementation classes we are having? These three implementation classes. And internally, hash set also internally, it is extending from this particular abstract collection. And finally, it is trying to implementing this particular collection. And here, so each class we are having separate interface here. We are having separate interface. Now, if you say this, array list internally, it is implementing this particular list interface. Okay. And the same way, linked list is also internally, it is implementing this particular list interface. Okay. And now observe carefully. So these are all the abstract classes we are having, and internally it is implementing this particular list interface. So finally, what we need to understand, so indirectly we are having the relation to this particular same collection, and directly we are trying to connect with the same, because array list internally it is extending abstract list, and abstract list internally it is extending abstract collection, and abstract collection internally it is implementing collection. And if you come to this array list internally it is implementing list interface. So this is the list interface I am trying to write here, and this particular list interface internally it is extending this particular collection interface. Okay. So this is the hierarchy we are having. This is very important, we need to understand here. Okay. So this is all about the one of the implementation class called array list. Same way it is applicable for this particular linked list here, and same it is applicable for this particular hash set, linked hash set, and tree set here. But only the thing, these three classes are internally implementing this particular set interface. Okay, internally it is implementing from this particular set interface here. Okay. So we identified whenever we are trying to discussing about the each and every class, how the relations we are having. So now we discuss about this particular abstract queue. Abstract queue internally is extending from one class called priority queue. Okay, we discuss about this particular priority queue. So priority queue is trying to extending this particular abstract queue, and the same hierarchy. Internally, it is trying to connect with the abstract collection. And if indirectly, now if you see, it is trying to implement from this particular queue interface. So priority queue is implementing the queue interface, and it is trying to extending from this particular abstract queue. Okay. So this is the hierarchy we need to understand regarding this particular priority queue. Okay. Now if we observe DQ, so DQ is internally implementing from array DQ. So this is the class we are discussing right now, array DQ. Array DQ internally is implementing from this particular DQ interface. Getting the point? DQ interface, and directly it is extending this particular class. So directly it is trying to extending this particular abstract collection. It is trying to extend from this particular abstract collection. Okay. So these are all the relations we are having. This is very, very important, we need to understand, because directly or indirectly, finally we are trying to connect in this particular collection interface. Okay. So this is the super interface we can discuss, and this is the super class. Even though if it is an abstract class, we can call it as a super class. Getting the point? So if we know this particular diagram, we can easily understand how this particular the collection framework part 1, how it is implemented internally with help of this particular all the interfaces and classes here. Okay, so any questions here? Any questions regarding this particular diagram? Okay, so now if it is clear, now we'll go for this particular classes section here. So where this particular classes are implemented here, now I'm going to explain this. So this is the array DQ. If you observe internally, it is extending from this particular abstract collection and it is implementing this DQ. Okay, if I'm going to open this DQ, now you can see it is trying to extending from the Q interface. Now if you see DQ, this particular DQ internally, it is extending this particular Q interface, and this array DQ internally extending this particular abstract collection. Okay, so here only I'm trying to show you this particular abstract collection. Here now you can see abstract collection. Okay, so what are all the methods we are having? What are the methods we are having inside this particular object? So first we need to identify the constructor. Constructors are the very important. Now you can see, so before going to discuss about this particular constructor, so this the class is introduced in the 1.6 onwards here. Now it's trying to store the object inside this particular object array. Okay, same whatever we discuss in the priority queue, same way these objects are also we are going to store under this particular object array. Okay, so this is important. And after this, now what I'm doing here, we are having two variables, so head and tail here. Head and tail. Now this is important here. We'll see how this particular method is going to work. Now for this particular head method, now you can read, it's going to call the remove and pop-up method. And here now you can see less than or equals to or less than. Getting the point? So less than or equals to or less than. And here we are going to call the particular tail method add last, add method, or push method. Getting the point? So this is the purpose of this particular two method, like two variables here. We'll see how it is going to use internally. Now this is the max array size here. We are going to use the maximum value of this particular array. So this is the maximum value of this particular array here. Okay. So 2147483 some value we are having, and internally we are doing the some subtraction of this particular -8. And this is the grow method we are going to call internally. We'll see how it is going to work, the grow method. So now what we need to understand here, default constructor. So this is the default constructor we need to understand. Now how we are creating it, new object array we are creating. So it is a simple, the array example we discuss here, same way it is trying to create a object array. And what is the size here? This is the size. So how many elements we can store? 16. Getting the point? So some of them are having 10, some of them are having 11, and some of the classes they are having 16. So we need to understand very carefully this array DQ we are having right now 16. Okay, 16 elements we are going to store. And if you are not providing, if you are trying to provide explicitly, getting the point? So this is the one more constructor we are creating here. Again, new object array. We are providing this particular, getting the point? So new elements. How we are going to get this particular new elements here? If it is a less than 1, it is going to call 1. Otherwise, we are checking one more. If it is equals to this, we are going to call it as a integer dot max value. Otherwise, based on this particular new element, it's going to add one more value. Okay, this is something like a capacity whenever we are trying to give explicitly. If you are not satisfied this particular 16, you can give explicitly like a 5 or 10, something 20, 100, 1000, whatever the number we want to give. Getting the point? So default behavior this, and this is the custom behavior based on the custom capacity whatever we are going to provide. And another constructor we are having, and internally this constructor is expecting collection as a parameter. We can create a one more collection and we can pass to the parameter. And internally we are trying to call the constructor first. So is expecting one parameter. The one parameter how we are passing c dot size. So whatever the size we are going to pass here, based on this particular size, the constructor, it will try to create an object. So this constructor it is going to call, and it will try to create a new object array. After this, it is going to call the copy elements. It is going to call this particular copy elements here. Okay, these are all the constructors we are having. Only for like this is the first constructor, second constructor, and the third constructor. Only three constructors we are having. So we'll move on to the default constructor. Now here we created the default constructor. After creating this, now what I will do, AD is a array_dequeue, AD dot add method. So the add method is coming from the where? This method is coming from the collection interface, because each and every class by default it is going to implementing collection interface. So we can call this particular add method. Now what I'm doing is I'm trying to set this particular the a value. Okay, I'm trying to set this particular a value. Now if you observe carefully how this particular add method is implemented internally. To understand this particular add method, now what we need to understand here, first we need to understand this particular array_dequeue. So how many objects we are having? By default it is going to store 16 objects. Right now we don't have any objects here. So this is the first record we are trying to insert into this particular array_dequeue. Now observe carefully, I'm calling this particular, so value of method it's calling here. So why it is calling the value of? Because we are trying to converting into the char. Whatever the char value we provided, so it will try to convert it into this particular character. Now, so if this particular C value less than or equals to 127, because this is the range we are having. Getting the character range we already discussed here. Because of this, now we are making the condition this. After this, it is going to call this particular section. Otherwise, it is going to create a new character object and it will try to pass this. Now you can see, so it is satisfying this. Now it is trying to copy from the value character cache dot cache method we are going to call, and from this particular cache, now we are trying to converting into entry number, and after this again we are trying to converting into character. So here we are doing the two operations. So character, this is the C we are trying to provide as a character. Now we are trying to converting into int to load the value from this particular cache. After this again we are trying to converting into the character. Okay, so these are all the important information we need to understand. Now after loading this, now what happens internally, we are trying to converting character value. So after this I'm calling add method. Now if you see which method we are calling internally. Okay, whenever I'm trying to call this particular add method, I'm trying to call the add lost method. So observe these two methods performing same, but what is the differences we need to understand here? So what is cache? Cache basically, for example, this method like we are having, you can see we have a one cache method. Okay, it is expecting one parameter, and something like item is a parameter. Okay, so cache is a method. Getting the point? Cache is a method and it is expecting one parameter, and it will try to return the something like some value. So this value it is going to modify based on this particular item. For example, it is trying to return 100. Now what I am doing is this cache method, this particular cache method, it is going to call around 10 times. Getting the point? This cache method is going to call 10 times. Now whenever we are calling the 10 times, each time it is trying to converting database. Okay, each time it is trying to converting into the database here. Now whenever it is trying to connect into the database, now what happens internally, 10 times it is trying to communicate with the database to load the data. Okay, whenever you're trying to return the same data, getting the point? Whenever you're trying to return the same data for 10 times, now what we will do, we will try to store the data into the cache. Cache is a some location, it will try to available some certain time here. Getting the point? So based on the some certain time here, we can store this particular object. First time only it will connect the database and it will load the data, and after loading this particular data, it will try to set into the cache. So this is the one cache object we are having. Here I'm trying to store the object, and for the second onwards, it will not hit the database. Getting the point? It will not hit the database. First, it will check the cache. If the object is available in the cache, directly it will load from the cache. Getting the point? So here we are reducing 9 times here. Here we are trying to reduce the 9 times calls to the database. Whenever you're trying to make a call to the database, the performance will give you the some like lower performance. So we are not going to get high performance here. So because we need to open the connection and we need to communicate the request, and here we are going to build the like database queries, and after that we are going to make some condition, and later it will try to load the data. So loading data also this is very important, because so we are going to have some lakhs of records. Getting the point? Some lakhs of records if we are going to have in the databases here. So this perform is going to take some time here, because it needs to identify the value based on the conditions. Once it is identified, then only it will fetch the data. This identification is going to take some time based on the value, whatever the value we have inside this particular database here. Okay, so if you're trying to do the 10 times, now you can imagine for each and every request, if you're trying to communicate with this particular database, how much time is going to take to load the data from this particular database. Instead of loading the each and every request to the database, now what we will do, we'll create a cache here. Only first time it will communicate with the database. From the second time onwards, first it will check the cache. If the data is available in the cache, it will return from the cache. Okay, same way, whatever this particular character we are trying to store, because the character values are will same, because we are trying to converting into the Unicode format. So whatever the character will give you, the value will be same for every time. The value is not going to modify. Okay, the value is not going to modify. Whenever the value is not going to modify, so it will try to return from the cache, so that the performance will get some little bit faster here. Getting the point? So that is the main advantage we are going to get from the cache. So we'll see the cache in our upcoming classes. What are the different caches we are having? Now you can see finally we are coming back to this particular add last method. So difference between add and add last method will identify here what it will do internally. Now I'm calling add last method. Now you can see this value we did not provide it as a null, so we are given as a character. Now internally what is doing it? It is trying to come back to the elements. So far any elements we created? Nothing. This particular element is empty. Now you can see how many objects we can store? 16 objects, like 0 to 15. So 15 is the last element and 0 is the first element. So that now we can understand here 16 elements we can store. And finally, now what I'm doing here, I'm trying to store into this particular ES. I'm checking here. So what is the tail? Right now it is a 0. Okay, head and tail we created two variables here. These two variables we are having 0. Now what I'm doing here, whatever the E we provided, whatever the element we provided, now I'm trying to set into this particular tail. So it is something like in the 0 index location, we are storing the A character. After storing, now I'm trying to check this particular condition. So ES dot length. So ES dot length is 1. Okay, sorry. So it is trying to including the all the default capacity. Because of this, it is trying to returning as a 16. Getting the point? So it is trying to returning as a 16. Why it is returning? It is a variable. Getting the point? It is a variable. So far, how many objects we are having? Because the default value we inserted as all the nulls, so it is trying to treat it as the 16, the values we are having. Now, what is the tail? Tail is a 0. Now, what we are doing here? We are trying to call one INC method. So this particular INC method, whatever the value we are returning, this returning the value we are trying to set into this particular tail here. Okay, we'll call this INC method how it is implementing. Now, if you observe I value 0, thus module we are having 16. Now, what I'm doing here, I value I'm increasing. Okay, I value I'm increasing here and I'm checking the greater than or equals to module. So this particular condition will not satisfy. Okay, this particular condition will not satisfy because modules we are having 16 and I value we are going to increase to this second value. Because of this, simply we are trying to returning I. Whenever I'm trying to returning this particular I value 1. Earlier it is 0. Earlier it is 0. Okay. This is, we need to understand very carefully. So observe carefully. After INC method we are calling, we are increasing this particular tail as a 1. After this, again, the same value I'm trying to set into this particular head also. Now, head and tail both are having same value. Now, if you see this, head will contain y. Okay, sorry. Here we are checking the double equals to operator. We are not initializing, just we are comparing here. Here we are initializing because single equal. Getting the pen. So tail we are initializing the value as a 1, but head still it is 0 because we are trying to checking the with help of this particular double equals to operator. Okay, this particular condition is not satisfied. Head is 0, tail is 1. So finally, only one record we insert into this particular ES. Simply we are returning this. Okay, we are returning true. Now what you understand here? This particular add last and add method. Only the add last method, if you're trying to providing element as a 0, we are going to get an exception. Okay, so this is only the differences we need to understand this particular methods here. Now I'm going to add few more characters here. So AD dot add method, I'm going to pass as a Z. So here we are not converting into any order here. Getting the point? Here we are not converting any order. So it's a simple one. We can easily understand something like W. So whatever the order we are inserting, we are going to get same. Now you can see AD dot add method, and I'm calling this something like D I'm going to pass. Okay. Finally, we'll try to print this particular AD. So whenever we are trying to print this, we'll try to identify here how this particular iterator is going to work internally. So the first record we identified. Now I'm moving back to the second one. Now you can see again this character method will call here. Now you can see the cache value it is returning. After this, we are trying to call on the same add method, add lost method we are calling. So far we inserted only one record here. Now you can see in the zero index location. In the zero index location, we are having one character. So that is trying to insert it as a. Now, so this is the tail. What is the tail value right now? 1. In the first index location, we are going to insert as a this particular Z value. After initializing, we are trying to check same the INC method. The INC internally it is increasing the I value. Something like the right now I value is 1. Now it will become 2. We are going to check with this particular head. So if you say this condition is not satisfying. Whenever the condition is not satisfying, we are not going to call this particular grow method. Okay. So same way, it will try to call all the add methods. So far, how many we are having? 4 records. So this is the last record we are inserting. Now we inserted the 4th record. So internally, object array is using, we are trying to store the data. After this, I'm calling the iterator because we are trying to print this from this particular abstract collection. I'm going to put a breakpoint on this particular toString method so that we can understand how it is going to work internally. Okay. Now abstract collection I'm at right now. Now I will print this particular toString. Here I'm getting the breakpoint here. Okay. Here I'm trying to put a breakpoint here. Now you can see after putting this, now I'm trying to run the toString. Now you can see abstract collection. So now we are at abstract collection. Okay, I'm calling the iterator. So this iterator is implemented from which class? ArrayDQ. So if I'm going to move inside this particular iterator method, now again we come back to this particular ArrayDQ class. So here you can see the name of the class name. Now after this, what we are doing is we are trying to create one iterator class that is called DQ iterator. So DQ iterator. So this is the specific class we created inside this particular ArrayDQ. If I'm going to show you this, so where we are having, this is the constructor I'm calling, and cursor is equals to head. Cursor is equals to head. Whatever the head value we are going to have, I'm trying to set into this particular cursor. And now you can see this is the private class we are having like a DQ iterator, and it is trying to implementing from this particular iterator. Okay, iterator is having two methods, has next and next method. Now we'll see how it is implemented. This is the has next. Okay, this is the has next, and this is the next here. Getting the pen. This is the has next, and this is the next method we are having. Now, what you can understand here. So how the has next is going to work. If you observe carefully, first time has next is size. First time has next is size. So far, how many elements we inserted? 4 elements. So if you're trying to inspect this, okay, we are getting null pointer. Okay, maybe it's because inside this. Let me try with this particular expression. Okay, I'm trying to call this particular size here. Okay, so what is the exception, like a expression we are getting here? So something like we are getting an exception here. We'll see how we can call this particular size method later. How it is implemented. Because of this particular inside the class, maybe we could not access this particular size method, but we'll see. We already identified how many records we are going to. We already passed the records. So if I'm going to open this, so it is calling the sub method. It is trying to returning tail head element dot length. So it is going to check this. Based on this, it will try to return the values here. Okay, no need to check about this particular size. We already familiar here. Now I'm coming back to this particular constructor. After this, we are calling the size. Now you can see it is calling this particular sub. Now if you see, so sub head is head or tail, what we are calling. So first one is tail, second one is head. So tail basically I think 4. So 4 is the tail value, and head is a 0, and modules. Modules we are having length 16. Okay. Now what we are doing here? So what we are doing here, and here I'm trying to work as a I minus j, and we are making the condition, and if it is matched with this particular I, we are trying to increase this particular module. Otherwise, we are trying to return this particular I. Now we'll see. So this particular condition, it is returning the I value. What is the I value right now? 4. So what is the size we are trying to returning? 4. Okay. This is the 4 size we are having, and last RET we are trying to make as a -1. Okay, now we identified the remaining. Right now we are getting as a 4. So this is only the size. When you are trying to call the has next, what is the condition we are making? Remaining greater than 0. If the remaining value we are going to get as a greater than 0, the has next method will return as a true. Otherwise, it will return false. Okay, now we identified this. Now I'm coming back to the this particular DQ iterator. So iterator is created. Now I'm calling this particular has next. Whenever it is returning the false, then only this particular condition will satisfy. So far, it will not return any false value because we are having some records here. So directly we'll go to the next here. So string builder, we are trying to appending this. It is an infinity loop. I'm calling the next here. So it is nothing but iterator dot next. Whenever I'm trying to call this iterator dot next here, we'll identify how it is implementing. So now you can see we are calling the next method. We are inside the DQ, getting the point, DQ iterator. So this is important here, how the each and every iterator is implemented in the specific classes. So remaining if to less than or equals to 0, will throw an exception. Get in the pen. This is important. We discussed the exception lining, how it is implemented. So here we are trying to throw an exception, and we'll see this has next is not handling any throws class. So directly it is going to throw an exception. The default try catch mechanism is going to handle this. Okay, this is all about the one of the important example we need to understand regarding this particular next year. So this particular condition will not satisfy. So once this particular condition will not satisfy here, now it will go to the next line here. So we are trying to load the elements. How many elements we are having here? Around 4. If you load this into this particular ES, it will contain 4 records. So 0 to 3, something like 4. A value, Z value, and W and D. Getting the pen. These are all the 4s we are having. After this, now what I'm doing is I'm trying to check this particular not null element at. So if you're trying to pass any null values, okay, if you're trying to pass any null values, what happens internally? So we'll see after seeing this particular method called not null here. So I'm moving into inside this particular method. Now if you can see, if you're trying to provide any null, it is going to throw an exception. Okay, it is going to throw an exception. So far, we don't have any null values here. Okay, simply we are returning the e value, something like element value. Now, what is the element we are having? First record is going to return. Getting the point? First record is going to return. So after this, we are trying to call the same INC method here. After calling this particular INC, the cursor value is going to modify. Right now it is 0. After come out of this particular 702 line number, cursor value will modify 1. Getting the point? The cursor value is now modifying here, and later we are trying to decreasing this. Remaining, so it is a post decrement operator. Getting the point? It is a post decrement operator. After this, we are trying to returning E. So whatever the element we loaded here, this is the E, it is trying to return here. Now you can see, so this is the E not equals to E this. So later the E value we are appending. Now if you see this particular SB, we added one array bracket and the character we added, and after this we are trying to come with the next line, comma and space. Comma and space we are appending, and later it will call one more time. It is calling one more time. The same, the next method will call. So if I'm going to show you the next method, again we are checking the remaining. Remaining right now, what is the value we are having? Something like 3. So 3 less than or equals to 0. So this is false. Now we are loading this particular ES. So based on this particular not null cursor, the element we are trying to load here, because the cursor value, what is the value? 1. The first index location, whatever the value we are going to have, we are trying to load here, and we are trying to set into this particular E. And after this, I am increasing the cursor value. Now if you see the cursor, now it will become second. Now it will become second, right? After this, we are the remaining we are trying to decreasing it, because we are checking here. Because of this, we are checking the like a post decrement operator returning E. So simple one. This is the way it will try to load this particular next value, and it will set into the string builder. From this particular string builder, finally it is trying to append this. So it is now appending the closing bracket, and after this it is calling this particular to string. So this is the values we are going to print here. Okay, this is the code is implemented internally inside this particular ArrayDQ, how the iterator is going to work. So any questions here? Anyone having any questions regarding this particular iterator method? Okay, so if we don't have anything, so try to like where is the ArrayDQ? So now we'll try with another method. So far the specific methods only we'll identify, because the common method we already familiar with multiple classes. We are not going to discuss any the common method. Now if you observe carefully, because the queue internally it is extending from the collection only. Whatever the collection method we are having, we are not going to discuss, because we already identify a lot of example here. So first we'll discuss about the queue related. So here add method internally it is calling add loss method. So we'll call this particular offer method. So how it is going to work? This particular offer method, and here offer method I'm calling it, and this offer method internally it is trying to store as a one more character, something like O. Okay, so here I'm trying to store O value. Now we'll understand this, how this particular offer method is going to work internally. So add method we are not going to call. I'm calling the offer method. Now you can see again we are calling this particular character cache related. So we'll come back to here because we are converting into the character. Now if you see offer last here, getting the point. So far we did not call this particular offer last. Whatever the add method we call, the add method, it is called the add lost method. Okay, offer method internally, it is calling the offer lost method. Now you can see insert the specified element at the end of this particular DQ. Okay, add method also it's trying to insert the element at the end of this particular DQ. But what is the differences here? That we need to understand here. Getting the point. Now I'm trying to call this particular offer lost method. And now you can see internally which method we are calling? The same method. Whatever the add lost method we identified here, the same add lost method only it is calling. Getting the point. Add last only it is trying to call this particular method here. Getting the point. Now, so we don't need to discuss this one more time because this particular code, so just now we discussed here how this particular add last method is going to call. Now, what you are understanding here, add last, offer last, add method. These three are the similar methods here. Getting the point. Internally, finally, which method we are calling here? Add last only we are calling here. So if you are trying to call add last method, directly it will call the add last method. And if you are trying to call this particular offer method also internally, it is calling one more method something like offer last method. Directly it is calling this. So this is the hierarchy, offer to offer last, and from the offer last to add last. Finally, so in every case we are calling this add last method here. But what we need to understand here, if you go to this, where is the collection? Anything we provided here? Here, offer last first and offer last, add last. Okay, now I will go to the DQ. We'll identify the differences here. Getting the point. The differences about the add last and offer last. So how it is going to work internally? How it is going to work this particular offer last here. So if you go to this particular DQ, we need to discuss about the, here we are having add first. We'll go to the add last. Now you can see insert the specified element to the end of this particular DQ, and if it is possible, so without the violating of this particular capacity. So if it is a capacitive, it is not going to violate anything. And here, so we don't have any specific information. It will try to throw this particular all the exception, but we identified the add last. Okay, now we need to discuss about the offer last here. Getting the point. Offer last method, what it will do. So now we need to understand here. So if you see, if this particular element was added to this particular DQ, it will return true. Otherwise, it will return false. Okay, otherwise it will return false. But the add last, it will return here. Getting the point? It will not return anything if it's going to throw an exception. Illegal state exception. Getting the point? So this particular, based on this particular capacity restriction, if the element we are not going to add into this particular, the add last, getting the point? If we are not going to add into this particular DQ collection here, so it is going to throw an exception here. But the offer last method, it is not going to throw any exceptions here. So simply it will return false. So this is the differences we are having. Okay, offer last and the add last we identified here. Now same way we'll discuss about the first related method, add first and as well as offer first. So offer first will return false and add first will return throw an exception. Okay, it will throw an exception. Now we identify the last method, how it is working, because offer method internally it is trying to call on the offer last, and again it is trying to move on to the add last. So finally ad dot add first. Add first. So here I'm going to add something like F. Okay, here I'm trying to add F here. Now we'll see how this particular add first method it is going to call. So offer method we identified just now. It is trying to insert the record last of this particular DQ. Now what about this particular add first? The method itself is saying it will try to insert the record at the first of this particular DQ. Already we insert this particular A as a first record, but we'll identify how this particular value it is going to store as a first record here. Okay, now I'm trying to debug the method. Now you can see, now I'm moving into the add first. Now if you see, so we are checking the null pointer. This is important here. The add first method, if you're trying to make as a null, directly it is going to throw an error. Same way, add last also, it is trying to throw an exception here. But what about this particular offer related? It will not throw any exception. Simply, it will return the false here. Okay, it will return the false value. Now you can see, now we are checking the elements and using this particular DEC. So here what we are doing is we are trying to decreasing here. So INC is nothing but increasing. Okay. So these are all the two methods we need to understand here. So here based on this we are trying to decreasing here. Getting the point? We are trying to decreasing. So you can see we are doing lot of operations in the line number 289. So what is the operations we are doing one by one we'll discuss here. First one, we are calling this particular DEC by specifying the two parameters. First one is head and the second one is length. Okay, this is the first operation. And the second one, whatever we are going to get this particular the descending, it will try to insert into head. We are trying to inserting into head. So this is the DEC, whatever the value we are going to get, we are trying to initializing into this particular head. And the third one, now what I'm doing it, so using this, getting the point, using this, here we are trying to load this particular ES, the head value, getting the point, in the head location, getting the point, in the head location, we are going to store this particular E value. We are going to store this particular E value. What is the E value we are having right now? F. F. But observe, first we need to call this particular method, and based on this particular return type, we are trying to set into this particular head, and this particular head now it is playing an index here. Getting the point? So now it is playing an index role here. Now we'll see how it is going to work internally. How it is going to work internally. Now I'm calling the method here. So which method we are calling? DEC method we are calling. What is the I we are having right now? 0. And what is the modules? 16. Okay, what is the modules we are having? 16. Okay, and you can see we are decreasing the value. So it is a 0. So I value already it is 0. I value here already it is 0. Now we are trying to decreasing. It is a pre-decrement. Now it is become -1. -1 less than 0. Now what you understand here, it is going to satisfy or not. Getting the point? It is going to satisfy. If it is satisfy, now what I'm doing here, I'm trying to decreasing this particular module size. So what we are doing here, I is equals to module -1. So something like 15. Otherwise, the I value -1. Getting the point? Now if you see this particular I value 15 we are getting. Here you can see. So in the variable section here now you can see the yellow one, it is highlighting 15. Now what you understand here, this condition is satisfied. Now we are trying to use the modules -1. Module value we are having 16. We did the -1, like we are trying to, so decreasing the one value, so I value will become 15. Okay. So now what you understand here, we are trying to load the I value as a 15. After loading this particular I value 15, now what we will do, we'll try to set into the head, and in the 15 index location we are going to store as a the particular value called E value. Now you can see in the ES I'm going to load. Now you can see in the 15 index location. Getting the point. In the 15 index location, now what I'm doing is I'm trying to set as the first character. Okay, the F character I'm trying to set in the 15 index location. So how we are doing it? This is the 289 is important. Is doing the 3 steps operations. Okay, is doing this particular 3 steps operation, and finally we are comparing head value how much 15, tail value we are having 5. So it is not matching. So it is not going to call this particular grow method. Now what you understand here, this particular add first here. Add first here, basically it is trying to insert the value from the last index onwards. Okay, it is trying to insert the value from the last index onwards here. This is important, we need to understand. If I'm going to print this, now we are calling the again iterator here. Getting the point. So iterator we already identified, so we'll directly move on to the next method. The next is important. So far what is the remaining we are having? Something like 6. Okay, 6 we are going to call the first value, and what is the value we are getting? F we are getting. Observe carefully, directly we are getting the F. How we are getting this particular F? Because we inserted in the 15 index location. Getting the point. Now you can see what is the cursor value? 15. How we are getting this particular cursor as a 15? This is important because head, whatever the head we provided, the head value we provided as like we initialize as a 15. Now the same value it is set as this particular DQ iterator. Getting the point. This is important because of this. Now this method is trying to return as the 15 index value. 15 index value. Okay, this is important, we need to understand. So if you say the internal logic, the I value we are having 15. Now easily you can understand in the 15 index location, whatever the value we are having, we are trying to load as the first record here. Okay, add first, basically it is trying to inserting inside the object array as a last record, but while fetching the records from the object array, we are giving the option to load as the last record as the first record. Okay, this is happening internally, but we need to understand from the second from the second record onwards how it is going to work. Now if you see the cursor, now it is modified to 0. Okay, by default the cursor we provided as a 15. Now whenever I'm calling this particular INC, now it is become 0. Getting the point. So this INC method is playing a very important role, loading the which value. So which value we want to load, this INC is playing an important role. Now if you see this, what happens internally? The INC, here we are passing the cursor. By default we pass as a 15 and ES.length, that is something like a 16. Okay, so we are checking. And I'm trying to set into this particular RET. So RET we are having 15. I'm passing INC. So I value 15, modules we are passing as a 16. Now if you see, we are increasing this particular, we are increasing to I value 15. Now it is become 16. Now it is trying to satisfy this particular condition. Whenever it is satisfied the condition, the I value 0 we are providing. Okay, I value 0 we are providing. Whenever we are providing this particular 0, the I value it is returning. Because of this condition, because of this particular condition, now the I value we are getting as a 0. Okay, this is important. After this, now what you need to understand here, returning E. The E, whatever the E value we loaded here, something like F, whatever the F value we are loading. Okay, this is the way it will load the all the values, even though we are trying to call this particular first record. Now what I will do, one more time I am going to insert as a first record. So this is important, how this particular first record is going to initialize here. So here I'm going to initialize something like G. Okay, this first record we identified. Now we'll see how this particular first record will work internally. Now if you see this, again I'm calling this offer method. So first method we are not discussing. This first method we'll discuss, because first we are going to load as a Z, later we'll try to load as a F, and later we'll try to load as these values. Okay, now this is important. Now if you see this, I'm moving inside this particular character method. Now coming back to the same add first. Now we are checking here and we are loading the element. Now if we observe this particular descending, this is important. ES dot length. Every time this will give us a same value, 16. Okay, right now what is the head? Something like a 15. Because the previous first method, the previous add first method, now it is made as a 15 here. Getting the point? So that is we already identified here. Now what you need to understand here, 15 and 16. We are going to call the decrement method internally. Now you see here we are trying to decreasing 14. Getting the point? 14 because I value right now 15. The I value we are getting right now 15. So it will decrease to 14 and this particular condition will satisfy. So 14 is the less than to 0? It is not. Getting the point? 14 is not a less than to this particular 0. So simply we are returning 14. So now what you understanding here? In the 14 index location, we are going to store as a z value. Okay, now you can see I value 14. Here it is showing the value. Now if I'm trying to come back to here, in the 14 index location, whatever this particular g value we are having, we are trying to load here. Okay, we are trying to load this. So now if you see, after coming to the 290, if I'm going to show you this particular ES in the 14 index location. Okay, in the 14 index location we are having g value. In the 15 index location we are having f value. But while loading this particular value, now what happens internally? G will come as a first because we are trying to call the one more time add first method. We'll see how it is going to work internally. Head value 14 and tail value I hope 7. So it will be 7. Okay, still it is in the 5. So maybe because of this particular add first method, it is not updated here. Okay, the tail method it will work on only last purposes and head method will work on the first related purpose. Now we understand the why they define these two variables here. After this, now I'm going to this. Now I will call this particular iterator. As next we are not going to call append method I'm calling. So this is important. Next method. Now you can see. So what is the cursor value right now? It is 14. Get in band. So just now we inserted the in the 14 index location the particular g value. So right now cursor is 14. Now which value we are going to load? Get in the pen because whatever the value it is available in the 14 index location, the value is going to load as a first record. Now if you see, if I'm going to call this, here we are having object array and I value it is 14. So in the 14 index location, whatever we are having, we are loading this. Okay, we are loading this. So it is a simple one. Now we'll check this. So this particular value, now we loaded the g value we are loading. Okay, G is the first record. After loading this is important. The cursor now it's going to return 0 or it is going to return as a 15. It will return as a 15. So how it will return as a 50? To understand this, we need to move on to the INC method. So what is the I value? 14. And what is the modules we are having? 16. Now if you see, it is become 15. Okay, it is become 15 because we are increasing pre-increment operator like plus plus the variable. So the value will increase and this condition is not going to satisfy because modules we are having 16 and after increasing this particular I value, it will become 15. Now if you see 15 greater than or equals to 16. So this particular condition will give us a false here. So once it is given as a false, I value only we are returning. I value right now 15. I value we are trying to returning as a 15. So for the second iteration we are going to load as a 15 value. The cursor now 15. Now what you understand? First we are loading the 14 value. Later we are loading the 15 value. And later we'll move on to the 0. So this is the way of implementing inside this particular add first, add last method. Now you can see. So one more, the next method we are calling it, and this next method will play an important here. So cursor we identified 14, sorry 15, 14, and now it is increased to 15. So once it is increased to 15, now what we will do? We'll try to get in the point. We'll try to load the value from this particular non-null element at method, and after this, the INC it will return as a 0 because this I right now 15, it is going to increase as a 16. Now the condition will satisfy I value 0. I value 0. Okay, this is important. And cursor value we are going to get as a 0. After 14 and 15, now it will go to the 0. From the 0 onwards, it will try to load the 0, 1, 2, 3, 4 records. So this is the way of loading the value. G is the first element, F is the second element. After this, whatever the add or method we called here. Okay, because here the add method internally it is calling the add last method, and add first method it is trying to insert the record in the first of this particular array DQ. Getting the point. So this is very important information we need to understand regarding this particular array DQ. Okay. So any questions here? Any questions we are having? These are all the very important example we are discussing regarding this particular array DQ, because now the position is changing here also, but the position will change only whenever we are trying to load an object. But in session case, so based on the index location, it is trying to inserting here. So now you can see add first and add last we identified, and AD dot offer first. Okay, offer first. So offer method internally, offer method, if you see this offer method, it is internally it is calling on the offer last here. But now I'm trying to call the offer first method. Offer first method I'm trying to call. Oh, it is a character. Now I'm trying to give as a string. And what is the value we can provide? So FGI. So something I value I'm trying to give. Okay. Now I will show you the code how it is going to work internally. Add first we are calling. Add first only we are calling. Getting the point. So from the offer first, again we are calling the add first. So add first, what it will do? Same code. Whatever the code we identified just now, it is calling internally. Okay. Add first here, it is not returning anything. It is not returning anything. But offer first method is returning true. Okay. Offer first method it is returning true or false value, but add first method is not going to return anything. Directly it will throw an exception. So by seeing this particular method, we can easily understand here. Offer last also same. It is returning true or false. Add last will not return anything. Directly it will throw an exception. Okay. So now you can see here we are going to throw an exception. If we are not throwing here inside the INS, not INS, from the next method again we are going to throw an exception. Getting the point. Now you can see in the grow also, nothing. If I'm calling new capacity, here we are going to throw an exception. In the new capacity, we are going to throw an exception, illegal state exception. So this is, we need to understand regarding each and every method, how it is working. For the add related method, directly we are going to throw an exception. But offer related method, we are going to simply return true or false. Okay, these are all the methods we are having. So I'm requesting here, try to practice all the method, because we already familiar this particular methods here, all the offer first method, add first method, and last method. And what about this particular get method and pull method? First method will return the first record, and the last method will return the last record here. What is the differences we need to understand? Only some method will throw an exception and some method will not throw any exception. For simple example, I'm going to call the pull first method. Okay, so if I'm going to call this particular pull first method, how it will work internally. So I'm showing the code how it is going to work internally. Now you can see, and what we are doing it, we are trying to load the object arrays. So far, how many objects we inserted? Around 6 objects. Okay, 6 objects. Now if you see head value, whenever we are trying to check this particular head variable, it will try to load the first values. Okay, it will try to load the first characters. If we are having tail, we can understand here, it will try to load the last values. Okay, now you can see, yes, we are having, and h variable we are trying to declaring, and we are calling the element set method. Now passing this elements is equals to es we are passing, and head is equals to h I'm passing. Finally, 2 variables we are passing, like first one is a object array and the second one is the index. Based on this particular object array and index, we are trying to load the value. Okay, so head value most probably 14 or 15 we are going to give. So based on this particular value, it will try to return the appropriate value here. So once it is loaded, if it is not equals to null, we are trying to set the current value as a null here. Based on this particular index location, we are making as a null and will return the whatever the value. So once the object is written, we are going to making as a null. Okay, so this is the important information we need to understand here. So I'm requesting here, the whatever the remaining, the peak method and the poll method, whatever we are having, try to debug this particular methods and you will get understanding here how it is implemented this particular array DQ. Okay, so some method will throw an exception, some method will not throw any exception. This is only the differences we need to understand inside this particular array DQ. So any questions here? Any questions so far?
Sir, I have one doubt. What is the difference between add first and offer first, sir?
So that is only I'm saying, right? If you see the code, add first, here it will throw an exception. Okay, offer first, if I'm trying to show you this, offer first method, it will try to return the true. Only true or false value it will return. It will not throw any exception.
Okay. Okay. Thank you.
Okay, so same way I'm requesting the remaining method, the pool method and the peak method. So if you see the differences here, it will give you all the information. Now if you see, after coming to this, after remove related section, now pool first method. So it will retrieves and it remove the first element. Getting the point? So this particular pool first method now what is doing it? It is trying to load the object, and whatever the object we loaded, the specified index we are making as a null, removing. Here it is removing. So simply we identified here. So if I'm going to provide this particular same pool first here based on this particular elemented, we are loading the value. After loading, I'm making the null. Now what you understanding here? If you are making the null, this particular object is no longer available. Which object is? Whatever we are trying to load, the line number 3 ID, because we are trying to inserting null. Getting the point? So this is we already discussed here. The right side value, it is going to store in the left side in the H index location. Now where we are getting this particular H here? Here H is equals to head. Getting them? For example, H like head value, it is a not 16, 15. In the 15 index location, we are inserting as a null, so that from the next time onwards, we are not going to get this particular 15 records here, because the 15 record is null. So if you see the opposite, one more method, if you go to this particular DQ, pool first we identified, and if I'm going to show you get method, not get method, and peak first method, but this particular method, just it will retrieve, but it will not remove the value. Okay, just it will retrieve the value, it will not return, like it will not remove any value. So this is the differences here. And here, if this particular DQ is null, like if it is the element object array is null, so it will simply it will return null. And to come back to the same, the pool first method, now this is also, it is returning the null, but only the difference is here, it is removing, and this method is not going to remove. So if I'm going to copy this, we'll see the code how it is implemented. Not this here. Control O, Control V, and peak bus. Now you can see directly we are calling the element at. So see the differences. Directly we are calling element at method. So here we are this method we are calling, and we are passing the elements and the head here. But the last and first method, if you see what we are doing it. So where is the peak pool last method? So yeah, this method. Now if you see this, we are after loading this, if it is this is not equals to null, we are making the null. And for the same the peak first method, now if you see here we are not doing anything. So simply we are returning this particular value from this particular element at whatever the object to whatever the element we are going to load, the value we are returning here. So there is no remover logic here. So this is we need to understand each and every method. Okay, so this method you will get to understand whenever you are trying to debug the code. Get in the point. So while debug this particular code, you can easily understand how it is implemented each and every object here. So peak last also is doing the same, peak first also is doing the same, and get last method, if it is null, we are going to get an exception. Otherwise, it will simply return this get last method. Same way, get first method. So directly we are loading the value, and if it is null, we are going to throw an exception. So otherwise, it will return the value. So get first, get in the point, get first, and peak first, and pool first. So these are all the three methods. These three methods will do the same operation. It will try to load the object from the object array, but the difference is here, this pool first removes whatever the object we are going to use, like whatever the object we are going to load, the pool first method will remove the object after loading. And here, the another important here, here get first method. If the get first method is trying to return the null, okay, if the current object we are trying to return the null, it will throw an exception. It will throw an exception. So this is something like get first method. Okay, and the another last method, peak first method. So simply it will return the value, or we can call it it will simply return the element here. So it's not going to throw any exception. It is not going to remove any object here. So these are all the three methods will do the same operation. So pool first method also it's trying to load the value from the object array. Get first also it's trying to load the value from the object array, and this peak first also it's trying to load the value from the object array. But only the difference, it will remove the object after loading, and if the object is null after loading, it will throw an exception, and it is not going to do any other operation. Simply it will return the value. If it is null, it will return the null value. Otherwise, the original value is going to return. Okay, so same way we'll have the different three more different values for the last method, and two more different method we are having for this particular removal method. Get in the point. So most of the code I explain here, but remaining code you can work on the whenever you're trying to debug this particular ArrayDQ. Okay, so any questions here? Okay, so the cursor basically, if you go to this particular where is that, I hope next method, descending this, if you say this particular next method, before going to discuss about the next method, this constructor we are calling, so DUQ constructor, and whatever the head value we are having, the head value we are trying to set into this particular cursor. Getting the point. Whatever the head value we are having, we are trying to set into this particular cursor. Because of this, the cursor value is modifying here. First time, this cursor value 15 or 14 we are going to get. After this, we are trying to call this particular INC. We are calling this particular INC method. Internally, it is updating the value based on this particular length here. For example, this particular length every time we'll get as a 16. And now if you go to this INC, the modules we are going to get as a 16. And if it is a I value 14 or 15, here we are using the pre-increment operator. Based on this pre-increment operator, the cursor value is modifying here. Okay, So because of this only I'm requesting you debug the code. So try to write the ArrayDQ example like this and debug the code 1 or 2 times here. You'll get to understand, because we already provided the shortcuts here to debug this particular all the collection classes here. Okay, so go through the all the classes and debug the code. You will understand. If you are not understanding, so let me know. In the tomorrow session we can discuss wherever, like where you're stuck here. Okay, anything you want to discuss? Okay, so anyway, so tomorrow we are going to discuss another topic called map. Getting the point? Map is a one interface we are having. First we'll see the what are the different interfaces we are having, because we already identified map is going to store key value pair here. Okay, so some of the classes we already debugged here, but one more time we'll debug the code and we'll see how each and every class is implemented internally. And so tomorrow we'll continue this particular map related section and we'll see what are all the different example we are going to cover. Okay, if you don't have anything, I'm going to stop the session up to here. We'll continue tomorrow with a new topic here.